We'll have a look at example 2 now. Our vessel's to load cargo of grain. The stowage factor is 1.55 metres cubed per tonne. Initial displacement 7,000, kg 6.4. All 5 holes are going to be loaded full, and the tween decks are going to be loaded as follows. Information given there. Using the maximum permissible grain heeling moments table, we need to determine whether our vessel complies and the approximate angle of heel after assumed grain shift. So the tables we're interested in here, in your book you've got your grain heeling moments, full holes, the grain capacity is given, the volumetric heeling moment that we allow for in all the holes when they're full, and of course also the kg of the hold. So once we've worked out the weight of the grain in number 1, for example, we'd multiply it by the kg to get the vertical moments. Tween decks are all given as well if they're full, the grain capacity, volumetric heeling moments, and the kgs. Then let's have a look at number 1 tween deck. If these aren't full, you'll be told that they'll be loaded to an ullage, a certain ullage. So for example, it was an ullage of 2 metres. We can see that the volume of the grain will be 1324, the heeling moment 1577, and the kg of the grain. And you can see that the less the ullage, the less the volumetric heeling moments. The greater our ullage, then the greater the heeling moments up to a certain point, and of course then once the ullage becomes so great, the moments reduce again. But they start increasing and increasing, and up to about 3.75, 3.5, you get the maximum volumetric heeling moments to allow. So what we do, we set out all our holes, get the heeling volumetric values from the tables. So for example, number 1, 2, 3 and 4 values are all written there. We've got 2215, 4672, etc, etc. 2215, 4672. Obviously the number 1, 2 and 3 and 4 tween decks, well particularly 2 and 3 tween decks, they're lesser values because we've got ullage, and you can see that the volumetric heeling moments allowed for these two is far greater than the others because of course they have an ullage. So we've written down our volumes from the table. We must then divide the volumes by our stowage factor to get the weight of the grain. Obviously the first value we put in is our initial displacement, kg. Now we've got the weight, we get the kgs from the tables, we can multiply the weight times the kg to get our moments. We would divide our moments by our total weight to get our kg of the vessel. And we can see here from the tables, from our calculation here, our final kg is 6.69. We then have to add up all the volumetric heeling moments that potentially could occur on the vessel, and they come to 10,755. What we then have to do, we divide the volumetric heeling moments by the stowage factor, and that will convert it to weight heeling moments, and we've got 6939. What we then do, and there's a table in your book, but we'll have a look at the table in the separate stability data booklet. Along the top are kg values, so we would find our value of 6.69. So we've got 6.6 and 6.7. We would then go down to find our displacement, our final displacement, which is 19,444. So we can see here between 19,000 and 19,500 we would go between 6.6 and 6.7. So in effect we've got these 4 values, and we have to do 2 lots of interpolation to find the actual value that occurs at a kg of 6.69 and a displacement of 19,444, and we find that it is 8,221 from the tables. Therefore the vessel complies because our weight heeling moments, 6939, are less than the maximum permissible. And to calculate the approximate heel, we simply divide the actual heeling moments, 6939, by the maximum, which we've just got from the tables, 8221. And of course it's got to be a percentage of 12 degrees. So we simply multiply it by the 12 degrees and it tells us that it's 10.1 degrees. So the vessel complies because the angle is less than 12 degrees. And that's how we would do that particular problem. We don't have to draw up a GZ curve. We simply have to use the tables, the volumetric healing moments and our maximum permissible healing moments from the tables to solve that particular problem.